And what we are going to do next is get this sucker moving on to the main event. And that means our very first presentation of the EcoCast today. And this comes from Scale Computing. Presenting for Scale Computing today is Mike O'Neill, the Director of Solutions Architects in North America. Mike is here in the house. He is ready to go. Mike, here we go. Thanks for being here today. Are you ready to go, sir?
Ready to go. Thanks for having me.
Outstanding. I'm going to hand you the virtual mic, so take it away, please.
All right, a bunch of mics coming at you. Here we go. As noted, guys, everybody, thank you for your time being here first and foremost. I appreciate it. I'm going to give you a little history of Scale Computing and how we can apply the native security stance that we have in place to help secure those healthcare environments specifically across the board, as well as others that fit the need. Now, a little background here, as I transitioned through this, I discovered HCI about 12 years ago when I was searching out a virtualized solution for my company. And that led me to Scale Computing. So not only do I wear the hat as a Scale Computing employee today, but I was also a customer and I have the privilege and experience of being such. So let's get started with a little history in terms of how that works for us. Now, HCI, of course, you all probably know the buzzword that's been out there. It's very simple. It is the integration of compute, storage, and virtualization layers of infrastructure into a single solution architecture. Now, with Scale Computing, what we have done is brought this to the table with our Scale Computing platform. Now, Scale Computing, our virtual infrastructure, is the result of separating the physical hardware from an operating system into a virtual environment. Now, with this virtual environment, infrastructure also removes the inefficiencies of the physical hardware, such as the physical space and the cost of maintenance. Now, this was introduced many, many moons ago in the style of what we now know as the inverted pyramid of doom, or a 3-2-1 architecture. Now, it considered VMs running on clustered host servers connected by networks and supported by the shared storage appliances like a SAN or a NAS. Now, with this architecture, of course, there was a combination of components from different vendors, and that led to several challenges. Now, one of them being complexity. All the hardware layers had their own management systems, support services, specialized training, and usually had to have a few experts in the house to manage all that stuff. Expandability was also a challenge. Scaling up or scaling out was difficult, and a lot of downtime or costly upgrades usually were associated in that conversation as well. Now, there's also, unfortunately, the single point of failure that gets introduced with a shared storage platform. That shared storage often leads to expensive redundancy measures or backups as the primary way to recover from those issues. But despite the drawbacks, 3-2-1 has been in place for a long time, and it provided the essential features that we have adopted at Scale Computing, like high availability and live migration of VMs, that make it a very viable option for virtualization and has been for many years. Now, the more efficient alternatives that have emerged, of course, are in front of us today, and that comes with the idea of converged infrastructure. Converged infrastructure was developed to address those complexities that we just dropped through with the 3-2-1 setup. And they're basically pre-tested to avoid problems and complexities within, and often come from a standpoint of the same separate components, just pre-installed, pre-wired, if you will. The next evolution involved integrating all of those components into a single appliance, allowing for additions of compute resources to the storage and virtual machine setups. Now, while they improve that deployment and management, they often retain similar inefficiencies of that 3-2-1 architecture. The vSANs, or virtual storage appliances that were brought to the table with these systems to manage the storage, consume a lot of CPU and RAM, and that limits. And we've taken note of that, and years ago made that a note to us that we wanted that leverage of, or that layer, I should say, of complexity in reference to those components to be taken to a much better place. Now, of course, with those inefficiencies, the flash storage side of the world comes to the table to help support and give those inefficiencies a little bit more horsepower under the covers. Now, if we move on to that VSA model I just talked about, HyperCore on our side of the world is the ability for us to manage that storage at a fraction of the resources. As you can see here, just 4 gigs of RAM per node to start off with. So that gives us a lot of resource room to run the workloads and potentially leading to an overall reduction of the hardware resources in some cases. So a savings introduction from the start, if you will, on that side of it too. Not to mention you get the high availability that we talked about and still those reusable resources across the board. Now, there are 2 key components that make this a thing for the scale computing platform to work together to eliminate a lot of that management and intervention. AIM, the Autonomous Infrastructure Management Engine, is our AI ops engine before AI was cool. AI was just described here a lot as it's coming to fruition across a lot of verticals and a lot of workloads. And then Scribe, our scale computing reliable independent block engine, can help alleviate the traditional management headaches and complexities that were noted previously here. Now, if we look specifically at the healthcare side of the world, regulatory compliance is vital, obviously, to protect against security breaches. SC Platform is designed to simplify the complex processes by embedding the compliance into its core architecture. That way we can ensure the adherence to standards is an integral component rather than an afterthought. Now, a few pieces of the SC Platform that support this are our integrated security controls. We're compliant with major frameworks like GDPR, HIPAA, and PCI. We bring data protection to the table with built-in encryption via virtual TPM, access controls, and audit trails to secure some of that sensitive data. Policy management tools are also used to enforce and management security policies and align with the regulatory requirements. Another key component is regular updating. Ongoing compliance and support through the updates and features are simplified and help to align with the audits that you're forced to go through. Now, SC Platform not only addresses the technological needs, but it also supports broader compliance from a standpoint by establishing goals to integrate policy management and that adherence. Now, if we kind of jump into a security stance from a broad standpoint, from an overall architectural view, SC Platform is secure by design. It is secure through simplicity, and it is secure by default. We make the product secure by default, and with a secure design in the software stack itself, it leads to a simple to use product for our end users. Now, we start that venture with HyperCore. Secure by design and HyperCore exemplifies this. The principle with its integrated hypervisor in the HCI model, which is KVM, it contrasts sharply to traditional setups like the 321 model or other HCI solutions that leverage that VSA appliance we talked about earlier. Unlike the older models, SC HyperCore integrates web-based management directly into the system as well, creating a secure, self-contained appliance. Some key security advantages here. We have reduced attack surfaces. Traditional setups with separate management servers and external SAN or NAS storage introduce multiple surfaces for attack vectors and complexity. This increases the risk of misconfigurations and network attacks. HyperCore's integrated design reduces those risks by default. Now, disaggregated solutions from multiple vendors also complicate patch management and security updates. HyperCore controls the entire stack. This allows patches to be applied across all components simultaneously, ensuring quick and secure updates. Now, the bottom line is HyperCore's design enhances security by minimizing attack surfaces, simplifying patch management, and providing comprehensive protection against cyber threats, all while being easier to manage than the traditional and some other HC models that are out there. Now, one key component we bring to the table for this is our Fleet Manager product. The architecture of platform extends beyond just HyperCore to include Fleet Manager. This is a cloud-based tool that orchestrates and monitors fleets or multiple clusters out in the field. A key security feature of Fleet Manager is that it is outbound-only communication strategy. Traffic is initiated from HyperCore. This is running on-prem. Now it's behind a firewall, and then it talks to Fleet Manager, allowing for only those outbound connections. This enhances security. The outbound-only approach prevents unauthorized access by eliminating open entry points for malicious actors while ensuring that the network integrity is maintained. This has seamless integration. Fleet Manager and HyperCore work together to provide a secure and scalable solution for fleet-wide management, enhancing the customer experience while maintaining the highest level of security that we expect. Now, the bottom line is Fleet Manager's design with its outbound only communication significantly reduces the exposure to those vulnerabilities. Then it secures both data and transit, as well as the overall network footprint. Now, when we reduce the complexity, as we talked about, we can secure through that simplicity. Now, many of the features for SE platform are related to this. All of the features I'm about to cover have a common thread, and it is simplicity. They have to be intuitive enough for users to actually implement without misconfigurations and with full visibility to maintain them. One of the such is role-based access. Fleet Manager and HyperCore both offer role-based access controls, as you can see by these screenshots here. This will help restrict user access to specific functions and enhance security. An example here for Fleet Manager, we can allow users to perform certain tasks, such as just viewing the clusters without making changes, giving a cluster viewer only monitor access to take a look and see what's going on. Similarly, in HyperCore, we can enable users to be assigned roles like read-only, allowing them to monitor activity without alternating the workloads. It also supports creating accounts specifically for backup functions and limiting their actions strictly to that backup or snapshot capability. Audit logging and security-related events are the actions that HyperCore can take, along with being sent to a third-party SIEM tool to allow for syslogger API centralized monitoring and analysis. Now, the bottom line is the platform's role-based access controls provide granular control over user permissions and ensure actions logged and monitors for compliance. Now, further protecting the data is also important. When we talk about protecting the data, we can enhance security in these virtualized footprints with our TPM capabilities. Now, these VTPM capabilities, along with Secure Boot, can help maintain additional security stances. When we talk about Secure Boot, we are validating signatures in a cryptographic format. The signatures within this give us the ability to protect the software against bootloader attacks, rootkits, and kernel-level malware events. It also ensures that not only the software itself is protected, but it ensures that the authenticated software is loaded during that boot process, and it maintains the integrity of that boot process for all of those guest VMs. Now, virtual TPM, if you will, provides encryption key security that is very similar to physical TPMs, and enables the use of tools like BitLocker and Lux for encrypting storage within the guest environments. It protects sensitive data from unauthorized access and ensures that data integrity. Now, HyperCore support for Secure Boot and VTPN is a strengthening piece of our puzzle by giving you the security and protection of the boot process and securing that sensitive data with the robust encryption measures that you need. Another great option within the HyperCore and Scale Computing platform is part of our data security suite. That is immutable snapshots. Immutable snapshots are a key feature of the data protection suite, offering strong defenses against data loss, including ransomware attacks. Immutable snapshots, once they are created, they basically can't be altered. They live below the network layers within our block engine for further protection. They can be cloned for recovery purposes very quickly and very efficiently, but the original snapshot remains unchanged, and this provides a very reliable point of recovery. Of course, role-based access accompanying this as well can ensure that only authorized users have the ability to delete those snapshots. That adds that extra layer of security against access or accidental loss. Snapshots can be automated. This can be integrated into DR Plan, providing frequent recovery points locally or via remote replication that's built in as well to meet the organizational points and time objections, or RPOs and RTOs. HyperCore's immutable snapshots provide robust policy-driven protection against downtime and data loss. That makes them a critical tool for disaster recovery and cybersecurity, and it is built in by design. Another critical piece is updating your infrastructure and related hardware. Managing security across diverse devices and systems can be very complex. SC Platform simplifies this process. Hypercore updates process and the support in this activity is done in spades. It's an automated rolling update process requiring no maintenance windows. Proactive vulnerability scanning is a part of it with every Hypercore release. The vulnerabilities are scanned and addressed before the updates are even rolled out. Thank you, Strikeforce. This ensures that security remains robust and up to date. Our single-click updates are a piece of Hypercore, and this offers full stack updates, covering everything from BIOS and firmware to multiple layers through its software, and all of these are tested together for compatibility. This simplifies the process and encourages users to stay current with the latest security protections that are offered. Fleet-wide management allows easy application and monitoring of the updates across all the locations. This is done through our Fleet Manager product, ensuring the consistent security maintenance across even the most extensive deployments. Now, at the end of the day, Scale Computing Platform transforms complex security management into a straightforward process that ensures systems are protected with minimal effort. Now, getting to these systems is another piece of the puzzle that can be challenging at times. With Fleet Manager, we introduced the Secure Link feature. This is a simplifying secure remote access methodology that Hypercore clusters can use without needing traditional VPNs or jump servers. SecureLink establishes an outbound HTTPS connection from the cluster to Fleet Manager, allowing secure browser-based access to the Hypercore UI and console access to VMs. All of the data during those sessions is encrypted using TLS 1.2, and it has strict access controls and immediate disconnection after use to prevent unauthorized access. SecureLink also eliminates the complexities and vulnerabilities associated with VPN setups. This offers a cost-effective and streamlined remote management solution that's built in. SecureLink provides secure, efficient, and hassle-free remote access to the Hypercore clusters, enhancing security while simplifying IT management. Safety from the start is also a big feature and more of an idea across the entire platform. It's a philosophy. We embed zero trust principles into the core architecture to ensure security is an integral part of the system. All of software for Fleet Manager and Hypercore is developed internally by Scale Computing employees. This ensures strict security and quality control. Scale Computing Platform operates as a closed appliance with no root access. We only expose the necessary functionalities. This minimizes the attack surface even further and enhances security. Scale Computing Platform, secure by default design and tightly controlled development process ensures a robust, zero-trust security environment, reducing vulnerabilities and offering reliable protection without the need for extensive configurations. Now, our roadmap is very critical to where the security stance will go to and maintain. Scale Computing is reinforcing this with its commitment to top-tier security standards with some milestones that are on our horizon. Later this year, we're going to share the results of our SOC 2 Type 2 audit and ensure that data management continues to meet the high standards of privacy and security. Following this, we're aiming for ISO 27001 certification by the end of the year. This further validates our dedication to maintaining and improving our information security management systems. These efforts are going to reflect our ongoing strategy to exceed the demands of security compliance and protect our customers' data with the highest level of security. Now, you don't have to take our word for it. We have multiple case studies out there. Here's an example from Renee Jensen, the CEO of Summit Pacific Medical Center, that can address the infrastructure needs specific in this healthcare stance we live in today. Now, as we described, Scale Computing Platform is simple. Hypercore is built with the availability of a virtualized server in a SAN, the scalability and high availability benefits of a clustered infrastructure, and simplicity of a single server. It's available. Every virtual machine created on Hypercore clusters are automatically configured for high availability, meaning in the event of hardware failure, the VMs running on that failed node will fail over to the remaining nodes in the cluster automatically. It's scalable. HyperCore enables the hospitals or those medical centers to pay for what they need on a day-to-day, day one basis, knowing those systems could grow alongside their virtual environment and business needs in the future. With HyperCore, there are no upfront costs or licensing complexities. It's all right there in front of you. It is secure for all the reasons we already outlined in detail: role-based access control, secure link, VTPM, etc. We have all those things in spades to help align the security and best practices for those healthcare environments. Now let's take a quick minute and just dive top level and take a look at what that looks like for us today. So when we take a look at Fleet Manager, we see that this is a single pane of glass that gives us visibility to the entire environment, whether that be a single cluster, whether that be multiple clusters. We can see everything that's happening from a very top level entry to our environment across wherever our footprint might be. If we drill down further, not only can we see the versioning we're living on today, but the status of those clusters themselves. We can actually dig in and get access to those clusters. We can see what's happening from a resource perspective very quickly and very easily. We can see if updates are needed. Here's the updates that we talked about, the very simple process by clicking here. And then access through that secure link methodology we talked about before. You can scroll through, find the cluster you want to access. We can go ahead and select over here on the right, say you see the console access button. When I click that console access button here, very quickly and very easily, we can see that we get in and we have access to log into that cluster. When we're logged into the cluster, we immediately have access to those resources. And again, I'm not on a VPN here. This is that secure link access. You can see the token that we use right there. Once we're within the cluster, we have the ability to do everything we could, just as if we're sitting on-prem with those devices. We can make new VMs come to life by simply clicking this plus sign, filling in a few blanks, giving the information we need from a Windows perspective or other perspective. It's Linux, other types of operating systems. Here's where we would add the virtual TPM for the security and encryption topics we covered earlier. Carve out what we need from a CPU and RAM perspective. Again, noting that we don't need more than 4 gigs of RAM gives me a bunch of resources that I can apply at the VM level to those workloads. Carving out storage is also simplified. We did not get into great detail there, but we would I'd be very happy to get on a more in-depth demo to show you how this progresses through the ease of life or day one, day-to-day operational standpoint. Applying an ISO to those images is very quick and easy as well, and those live on the cluster through our media repository. Migrating is easy as well. In that conversation, we can simply leverage our import and export tool to get virtual machines migrated from any other hypervisor or physical environment, leveraging tools like Clonezilla. We can leverage the open text Carbonite / tools, their move icons there, or their move methodologies, as well as a very nice new migration tool with Acronis's convert to VM features. All those integrated directly to our product makes things very quick and very easy. We can also quickly upload virtual disks directly to the interface and boot to those. All these make the ability to run HyperCore through Fleet Manager and access to, as you can see here as well, the updates that we mentioned at the beginning. Very quick and very easy to manage as well. It's a simple click, see the release notes, hit apply update, and the system takes care of itself from that point forward, all the way through all the nodes in the cluster. This being a single node, there would be a downtime window. But of course, when you have single nodes, that is apparent. You're going to need to take some time off to do that activity. Back to Fleet Manager as well, you do have a very cool feature we call ZTP. ZTP gives us the ability to add nodes and deploy them remotely. Think of no boots on the ground. Think of someone that can simply plug in cables, get the information put into the system on your side from the admin side, and take that information back to create a cluster, stage it within the environment, and simply wait for it to land and get plugged in to come online and get deployed. You have visibility from those deployed clusters from that single pane of glass from Fleet Manager. You have all of your security stances and everything else to the point of ready to go within the Fleet Manager product and within the stance of HyperCore. All these things combined make exactly what we talked about. Simple, secure, scalable, all by design. So with that, I thank you for your time. Let's see, are there any questions out there we can answer for you today?
Hey, there are lots and lots of questions, Mike. That was a great presentation. And I love the demo at the end there, kind of bringing it all together and what you were discussing. I am sad to say, though, that with all of that information packed in, we have run out of time for questions. Mike, sorry about that, but I will say that I am sure Scale will be following up with everyone who asked questions. And there were a bunch of them today. They were just super engaged with your presentation, Mike.
We'll love it. We'll definitely take the fact of those questions and get back to those people as quick as possible with great answers.
100%. And I want to thank you for being here today and for just illuminating us on what Scale is doing. Always an innovative company. And I want to thank you again for being with us and for dropping some knowledge on us today, Mike.
My pleasure. Thanks for having me.
Thank you.